Okay, so we're now going to do the binary tree slightly differently to match how the exam board will ask for it in their big paper. So this is all about how we do it using their paper 4 variant of the new syllabus. So instead of using object-oriented programming, we're just going to use procedural programming. I'm setting up an array called array nodes, where we've got 3 columns and 20 rows. So it'll look kind of like this. X, D for data and Y. So we know that this would be our pointing left, so left pointer, and our right pointer, and the data. That's what it'll look like, times 20. It's in a 2D array. I'm setting root pointer to be -1, and I'm setting free node to be 0. Nice and easy. I've made a function called addNode, where we've got to pass in the array, our root pointer value, and our free node. And it'll return the updated information. So if we add a new node, root pointer will then turn to 0, this will be 1, and this will be whatever's inside our array. But let's have a look at addNode as its own function. So I'm going to go right to the top. Here we go. We are taking in 3 parameters: array node, root pointer, and free node. In this example, we're entering in numbers, but we could enter in strings instead. So we're entering an integer. This is our validation. So if the free node is less than or equal to 19, which means that we've got room in the in, array nodes, whatever our free node is currently, 0 will be -1. Array nodes, free nodes, 1 will be our data, which we've just entered here, and the right pointer will also be -1. So it would look like this. If we've got nothing entered in, we're going to have -1. Let's say I do 55, and then on this side, -1. Our free node, remember to begin with, is 0, which is why I'm putting it in position 0. If the root pointer is -1, the root pointer then becomes 0. So, to begin with, yep, root pointer is -1, so now it's going to become 0. Otherwise, if the root pointer isn't -1, we haven't actually placed our item into the array yet. Our root pointer is going to become our current node. So, let's imagine we've added this 55, and it's now wanting us to run this again. So we've added a node, so we've done this, what I've just highlighted, and we're going to increment the free node by 1 and return all our information. So now returned is going to be this information. That, and our free pointer is going to be now 0, and our free node is going to be 1. That's what would happen after the first time you run this. Yes, I need to put this below it, so let's do that. Actually, no, I'm just going to leave it like that for now. So let's add another node. So we're going to call our node, we're going to enter in our data. Let's do this time 22. That's going to be our data. 22. Well, we haven't placed it in yet, so place is false. Our root pointer, which is currently 0. Do you know what? Will it help if I visualize this? Yeah. Okay, I'm going to pause and put this onto a whiteboard. So let's just put it into this whiteboard to make it a bit easier. This is our function, this is our main code, and this is going to be our binary tree. Okay, so we said that we added in, I think it was 45, whatever. Let's call it 45. Probably wasn't, but whatever. We've got our root pointer, and we've got our free pointer. It's -1, root pointer is now 0, free pointer is now pointing to 1. And we're going to call array nodes again. What am I doing? we're going to call add nodes again, sorry. And we're going to pass in this plus this. That's what we're passing into the function. We're then going to enter in our next number. Let's do 22. If FreeNode is less than or equal to 19, which it is, array nodes FreeNode, which is our free pointer, which is 1, 1, 1. So let's put it in. This is going to be -1. This could be -1. As I've already done, this is 22. Position 0, position 1, position 2, position 3. Now, placed equals false. Root pointer value is now current node, so 0. I'm going to do another one, CM for current node. It's going to be 0. Whilst place is false, which it is, we're now going to run this code. And we're going to check to see if the node data we've just typed in, which is 22, is less than array nodes, so array, current node, which is 0, so is it less than 45? That's what we're checking. Is it less than 45? If yes, we're going to run this. If no, we're going to run this. So 22 is less than 45, so we're going to do this bit of a code. If array node, current node, which is 0, equals -1, yes it does. Current node 0 does equal -1, so we're checking this. We want to update that to become the free node. So free node, which is basically our free pointer, is 1. So we're going to replace this -1 with 1. Placed equals true. We don't do any of this, we don't do this else, we don't do this else. Free node goes up by 1. So the free pointer goes up by 1. It loops again, but we'll get to the stop of the loop and it breaks the loop because it's now been placed. We're all good. We return the information, so all of this is returned to the main code, this array, these pointers, etc. So let's enter in a different number. Let's do this time 36. So we're going to core. I'm going to pass in 36. So we enter in 36 here. If free node is less than or equal to 19, great. Array node's free node, which is now position 2, which is here. We're going to put in the node data, which is 36. We're going to put in -1 on this side and -1 on that side. We're then going to do our else because it's not -1 on root pointer. Root pointer equals current node. The root pointer is still 0, so that's 0. Okay, whilst place equals false. If node data, which is 36, is less than 45. So is 36 less than 45? Yes, it is. So we're now going to do this. If array node, current node 0, so position 0, is -1. No, it's not -1. So we don't do this bit. So we haven't actually placed our number properly yet. We haven't updated the index positions. So array node, current node 0. So current node 0 would be 1. Because current node is 0. And position 0 in our array is 1. Remember, that'll be 0, that'll be 1, that'll be 2. We're going to take that 1 and put it into current node. So current node is now 1. And look at why we're doing that in a second, because we're basically updating the index position. We've just checked it against this one. We're now going to check it against this one because before we do loop, so we're then going to loop. And then we're going to do whilst placed equals false. It still does equal false. Let me just clear up these X's. if node data, which is 36, is it less than array nodes current node, which is now 1. So let's go to here. Is it less than this? No, it's not. 36 is bigger than 22. So imagine a binary tree. We've got 45. We've got 22. But now we want to put 36 to the right of 22. That's what we're doing. This code is to do with the left, so we don't need this. We now need to go to this. If array node current node 2, so here, does that equal -1? Yes, it does. So let's put instead 3 node into here. So 3 node is our 3 pointer, so we're going to put in 2. Place becomes true, our loop breaks, and 3 node goes up by 1. We then return. And you'll see the pattern with this. So really, this bit of the code is to do with the left, this bit of the code is to do with the right. This is returning our values. So in this example, the exam board doesn't actually use the insert point, or the insertion point. So in the past, the exam boards have used 2 methods, one called add and one called insertion point. And what they do is they call add, they then run the insertion point to find where it goes. Does it go in here? Does it go here? Does it go to the left? Does it go to the right? And then add updates all the pointers. No, they've combined the 2 together, so we're just using add. This bit of code simply just prints all the nodes in order of the index table, which where's it gone? There you go. So it'll just simply print this. So it'll go 45, 22, 36. And that's what that would do. Which is basically what they're asking you to do here. Print or output each element in array nodes in the order they are stored. So 1, 20, -1, -1, 10, -1. That is basically what that is doing. This bit of code is simply adding 10 pieces of data or 10 nodes to our binary tree. So it's basically doing this table all the way up to 10 with the numbers going to be entered in. Where do we enter in those numbers? Remember, we enter them in the actual add node. But this is basically calling add node 10 times. So we're going to have 10 nodes in our tree. So if I do a quick recap of the code, we've got so far add node. We've got printing out all the nodes. And then got, let's just group this together, setting up a 2D array. We then got setting up our pointers. We then got our loop, which is going to be adding 10 nodes. Well, calling, shall I say, add node 10 times. And each time, it places it in to the correct position here. Apologies, I did have an indent error for 3 node. 3 node originally was indented here, so it's inside this else. That wouldn't work because, well, it would work, but it wouldn't work to begin with. What I mean by that is, if we've got nothing in our binary tree, so we put our first item in, if root pointer is -1, which it is, root pointer becomes 0, but then it keeps looping all the time without 3 node going up by 1. It hasn't had an opportunity to do that. 3 node would still be 0. So we need 3 node to go up by 1, no matter what, every time we enter. Even if it's a root pointer, which has been done, we still want 3 node to go up by 1, which makes perfect sense. Okay, we're now going to look at traverse. So the way InOrder works is the following. It will go to the bottom left first and display it. It will then go to the one above, and display it. It will then go to the bottom of the right and display it. It will then go to the one above and display it. It will then go to the one above that, which hasn't been displayed yet. It will then go right back to the bottom left again, above, bottom left again, above. That is InOrder Traversal. So in this example down here, this is the data I've entered, 33, 55, 11, 8. This is what's been outputted, because it does 8, then 11, then 33, then 55. But how did it do that? Well, this is our function. We pass an array node and a root node. If a root node is -1, we're done. However, if array node's root node 0 is not -1, so we're checking to see, if I just put this into something like this, in fact, I'm just going to tidy this up. Okay, there we go, it looks a bit more tidier. So let's go look at if array's root node, which to begin with is going to be obviously 0, which we pass in, doesn't equal -1, so this. Does that equal -1? No. So what's going to happen is going to, excuse me, it's going to call InOrder array nodes, array node, root node, 0. So remember how recursion works. With the very fact that it creates a stack. So let me show you how this will work on a stack structure. So these are the numbers which we've entered, 33, 15, 11, 8. Let's just add another one. Let's do 16. This is a binary tree, how it will be represented visually. This is just me in the order I've entered it. And this is going to be, in essence, a stack in itself. So what's going to happen is the following. Our root node, as we know, is going to be 0. So our first piece of data is going to be 33. It then goes to the left. How do we know it goes to the left? Because we're checking the left, position 0, and we want to get the next node. So the next node to the left is 11. That's an essence value. And it then does this again, so we call it again, sorry. And the next one, when it gets down to here, will be an 8. And then it does it again, and after 8, it's going to be -1. When it gets to -1 here, it'll put -1, null, here. And then what we're going to do is, we're going to unwind, we're going to pop things off. So the first thing is we can pop this off. Then what we're going to do is we're going to pop off, well, yeah, we're going to check to see if there's anything after this. We know it's 8 to the bottom, so we're done with that. So we're going to display that on the screen. I'm going to put display up here, 8. We're then going to check to the right of 8, because this is what we've just done. We've printed it, we're now checking the right. To the right of 8, it's -1, so we're done with that. We are done with 8. We're now going to go to 11. We know that we've just done 8. So 11 would basically, after 11 would be null, so we're going to simply print out 11. We've already checked the left, but now we've got to check the right of 11. That's what this is doing. When we check the right of 11, we do have something. It's not -1, it's 16. So I'm going to add 16 to our stack. We're going to check the left of 16, and there's nothing there. Because there's nothing there, we print it. We then check the right. There's nothing to the right of 16, so we're done with 16. The next thing to pop, so we go to the top, the next thing to pop off is 33, because 33 we've done 11, we've done 8. But now let's check the right of 33. 33 is not the end. We also have 55, so let's add that to our stack. We go down again, we check the left of 55 here. This is checking the left of 55. There's nothing there, so guess what we're going to do? We're going to pop it off. And that is in order. This is one way the exam board could ask you to traverse through a binary tree. In order. We then got post order. The way that works is, again, it goes to the bottom left, but then it also goes to the bottom right, and then back one. So we then go bottom left, bottom right, back one, back one, bottom left, bottom right, back one, bottom left, bottom right, back one, back one, back one. So it's almost like this, left, oops, left, right, back one, left, right, back one. So on 22, then we display, so it's boom, boom, back one, left, right, back one, and then display, and then back one. So how do we do that in code, and what would it look like? Okay, so the way this works is very similar to InOrder. So what we're going to do is, this is what it looks like for my data. If I was to type in 33, 55, 11, 8, it's outputted like this. Or like this, 8, 11, 55, 33. And I've added in 16 again. This is our binary tree, 33, 11, 8, 16, 55. So the way this works is first of all, we start off with 33. We then go down again to 11, so we're going to the left. We then go down to 8, and after 8, it's null, so we're going to return. Now, we check the left of 8, it's -1. We check the right, it's -1. Because they're both -1, because we do this if statement first, then if statement here, they're both -1, we then print 8. So I'm going to do 8 here, just like that. And what happens next is, it goes back to 11, so we loop back up, we're now at 11. We check left, left is done, but then we check right, right isn't done because right is not -1. So we're now here. We're going to push that, 16, we're going to check the left, clear, we're then going to check the right, clear, because they're both clear, they're both -1, 16. We then go make our way through the stack, so the next thing we're going to do, so we pop, is 11. We've done left, we've now done right, 11. We then go up to 33, where we've done the left, we've done the left, so it's done. But we haven't done the right, because it's this if statement, then we check this if statement, because if the right is not -1, we're going to call it again, so we've got 55 now added. We're then going to check the left of 55, it's going to be -1. We go check the right, it's -1, tick, and then we go back to 33 again, 33, and we're done. So that I forgot to add to this, so it should be 55 and then 33. And there we go. That is PostOrder. Okay, so the way PreOrder works is slightly different. It goes here first to begin with and it displays. It then goes to the left and it displays. It then goes to the left again and it displays. It then goes to its right and displays. When it goes to a new node, it checks the left and displays. There's nowhere for this to go. We then go to the top of the right and we display. We then go to the left and we display. We then go to the right of it and we display. We then go to the left and display, and then to the right and then display. So if you've been understanding the last few recursive functions, this one, again, should be pretty straightforward. You'll notice the print is at the top this time, rather than at the end or rather than in the middle. So our first number in our stack is going to be 33. And guess what we're going to do? Because it says print straight away, that's what we are going to do. So let's print it out, and let's do it here at the bottom. 33. It then goes to, if it's not -1 on the left, which is not, it's then going to go to 11, which then calls it again, which prints 11. It then calls the next one, which is 8, and then prints it as well. And now we're at our return, because we've got nothing there, it's null. We'll pop that. We've done the left. We now check the right for 8. There's nothing there. So tick. We go back to 11. So we're checking 11 again, which is now going to be -1 there. But at the right, we have 16. So when we call it again, we're going to print out this time 16. Because that would have been added to this. After we printed out 16, we check the left of 16, it's -1. For right of 16, it's -1. There's nothing there anymore. So tick, tick. And we've done all of the left of 33. So we've just checked the left of 33, it's -1. Therefore we check the right of -3 now, which is 55. So we're going to add that to that. It would have printed it off. And then we check to see, are there any more to the left of 55? No, so we're done. We then check the right of 55. There's nothing there either. Done. I should have done that earlier. And done. There's nothing to the right anymore. We've covered everything. And there we go. 33, 11, 8, 6, 55. Let's have a look at all of these algorithms next to each other. So we have our algorithms next to each other: InOrder, PostOrder, and PreOrder. Just to recap, with InOrder, the way that works is it goes down the left, starts at the bottom. In terms of displaying, goes up by 1, goes to the right, goes up by 1, goes to the bottom left again. And if you look at the algorithm, you should be able to see how that forces it. With PostOrder, starts at the bottom, goes to the right, up, starts at the bottom, goes to the right, up, up again. So then, to the bottom, to the right, up, to the bottom, to the right, up, up again, and up again. And again you can see in PreOrder, sorry, in PostOrder, how that works. We check for left, we then have to check the right, and then do our display. And then finally, our PreOrder starts at the top, and we print straight away. So notice where the prints are on each one. Notice that this code is the same on every order. It's the only difference is where we put our prints. That makes it easy.